Boom. We're in. Okay. All right, so you'll get this part too, which will be nice, so that you'll have this. All right, so let's do this very quickly. F of x equals 2 times the quantity of x squared minus 3x plus 2. So let's label and describe everything. So I'm going to point to something, and you describe it. So what is that? That's the name. Right. Okay, now when I think of this collectively, that's the output. Okay, and then this thing inside of there is the what? Right, input. Okay, because remember, inputs have to reside in an output, because if an input doesn't reside in an output, then you are going to have what you have, or you don't have anything to calculate, right? Does that make sense? Yes? So if you want to actually calculate something, what do you actually have to have? Yeah, you have to have an input. You can't have an input to get an output, or you're just going to say, I take this. All right, so there's that. All right, so what is this whole thing then collectively called? Right, that's your output expression, right? Your output expression could have an input, doesn't have to, and we'll talk about that today as well. So this is my output expression. I'm just going to call it an output for shortcut. All right, so then we have one last thing to label, and that is what? So we have to label within our output expression, we have to label a what? Our input. So in this case, what's our input? Well, which one?
The first one.
No.
The second one.
No. Both. Okay?
Which one?
Those are, yeah, I know. It's a trick question, right?
Oh my gosh. My brain doesn't
Input. Sorry. So those are your inputs, right? So there's that described label. So now we have all that information. Because today's whole topic is going to be evaluating not just one function. It's going to be evaluating a piecewise function. And by definition, a piecewise function has pieces, not two, has pieces, plural, which means I need to have more than one piece. I could have an infinite amount of pieces if I really wanted to, because I could have a dot that creates a linear relationship that goes on forever, right? Put what I'm putting down? Okay. If I have a linear relationship of dots that go on forever and ever and ever, do I have discrete or continuous information? Continuous. Why?
Because it doesn't end.
Right, it doesn't end. So you can't think of discrete as just being points, okay? Because you can describe information with a function that you know has a domain that is infinite, right? Everyone got that? Yeah or nay? Okay. So discrete is this idea that you can literally make a list out of it. All right, so that's why I was saying to you when you guys said, oh, it has points. No, that's not what it is. Okay? All right, so then I have to evaluate this f of x minus 4. Did you do that? Or did I come back to the show too early? All right, so go ahead. You didn't fill it in. Go ahead and solve it. Go ahead. Look at this. The first thing I'll do is this. 2x minus 4, the quantity squared, minus 3x plus 2, right? So there's the first. Oh, my goodness. So there's the first thing I should write. Thereafter, this is why I become extremely fast at these. Because I go directly to this, that this is 2x squared minus 16x plus 32, right? Oop, Minger made a mistake. Boop, boop. Right, plus 2. Right, so there's that. I'm done. That right away. That's what makes this quick for me, right? That little piece. So then I'll write the minus 3x plus 12 plus 2, right? Does everyone follow me on that one so far? Now the question is, how the heck did I go from here? So how did I do this piece, okay, to right there? And here's what it is. And I don't know if you got it in Algebra 1. Odds are you probably didn't. But here's what. Okay, this is how I do it. All right? This is the formula that you will get. All right? If you have a perfect square, you are now responsible for knowing this formula, because if you don't have this formula at least memorized by next chapter, chapter 4, okay, you don't want to have to memorize this formula and use it to do the concept we are going to do. So I'm going to save you some time and let you know that you have about 2 weeks to have this thing completely memorized and understand what each part represents, okay? And I'm about to show you what each part represents. It's pretty simple. Okay, if I were to actually multiply this together, a plus b times a plus b, all right? You would use this thing called FOIL, which I never remember. I'm going to use this thing called the distributive property, folks. Okay, FOIL, I just choose not to memorize things that are insignificant, that are only used in one case. This formula is not used only in one case. This formula will be used for completing the square, and completing the square you will forever need to know, especially when you get to calculus, and you get to calculus, and all of a sudden they throw completing the square at you out of nowhere, and they expect you to know how to solve the problem. So this is a tool you're going to need forever to hold in your bucket. okay? And don't lose it, okay? Don't take it on site and then leave it there by accident, okay? So a plus b times quantity a plus b. Well, when you multiply them through, you get a squared plus ab plus ab plus b squared. So what do you get? 2ab's. 2ab's. And it only works for this, right? It will always work this way if it's a perfect square. How do I know if it's a perfect square? Well, one quantity represents one side of a square. Guess how many sides of a square you need to calculate area? 2. Well, guess what you have if they're a square? They're the same. Okay, so exponent means multiplication. You have 2 of them, so you're looking at a square. That's why it's called a perfect square, right? So that's what you get. So this becomes a squared plus 2ab plus b squared. So how do you do that from this formula very quickly without having to think? You square the first term. You multiply those 2 together and double it. And then you just square the last term. What about the negative, Mr. Minger? Very simple. When you multiply those 2 together, what does it make? Yeah, makes a negative 2ab. Well, why is it still plus b squared? Because when you multiply a negative by a negative, it is a positive, right? So just memorize that formula, but you need to know that this formula comes from perfect squares because we are going to solve quadratics like this. X squared, and we won't, these are easy ones. These are the ones I'll teach from the beginning, but these are the ones you'll get tested on. 3x squared plus 2x plus 5 equals 7. I'll say solve that. You'll be like, but I can't factor it. I know. You're going to have to do it this way. All right? Pick it up, put it down. Okay. So, let's move forward now. All right, so this is evaluating a function. So today's goal is to get through this idea of evaluating piecewise functions. And if we get there, then I will get into the fact of writing the equation. So I'll give you a graph, and then I'll say, okay, let's write the equation and create these restricted domains. All right. So what I'm going to do is I'm going to give you an example. All right. And in that example, I'm going to talk about what this piece looks like, so you understand the notation of it. All right. And then I will tell you what all that means, and then we'll evaluate them. Right. So basically, we're literally doing this on repeat. The reason I'm moving into piecewise functions, I'm not doing another lesson on this, is because we're going to do the same thing, except we're going to do it with a piecewise function. Got it? Make it put it on, put it down. Here and there. All right. So let's do it with piecewise functions. So is it okay that I erase all this? It's on video. So if you said no, I was going to say to you, go watch the video. All right. All right. All right. So just joking. Just joking. I would never say that. I would leave it there if you needed it. Disclaimer for your parents so they don't get mad at me. Okay. All right, so here we go. You ready? Moving forward. Hey, can you check that I'm in the actual video really quick? Yeah. I want to make sure that I'm there.
Yeah, you're just in it. Don't move any farther
To the left. So this is no bueno land. All right, so here we go. So f of x is equivalent to, all right? And then we have this. And then also, great question came up last period. Just in case you don't ask it, I'm going to share it with you because it's a goodie. All right, so anyway, here we go. 1/2 x plus 4 comma. What do we always put after the comma? You have done these. You have made piecewise functions. Yes, you make an inequality. Why? What are we going to claim there? What am I now claiming? Think back to absolute value. What am I doing? Someone said it. I heard it. Yes, but there's a fancier way of saying it. I'm limiting something. Nope, not the x-intercept. That's what we would calculate if it was absolute value, right? But what happens after that? Okay, so we're placing a restriction on the domain, okay? So I'm going to claim this. I'm going to say x has to be less than -4. You are the same way. All I asked Josh was for a fancy way of saying it. You are limiting the x values, as Josh said. I was just asking for a fancy way. That's all. Got it? Okay. So this is what we call this column, right? After that column. So what you will have in this piecewise function is you will have the expression. Okay? And then thereafter that comma, you will have the domain restriction. Okay, so that's what piecewise functions will be for you. So the expression that we have is 1/2 x plus 4 so long as the domain is an x value less than -4. Got that? Pick it up and put it down. So let me do this. Whoop. So I'll make a function with just 3. Now these won't be exactly the same as the next period because I'm going to alter them a little bit for a reason. And then we'll do another one, so then we'll do this. Okay. All right, so a couple of things I will ask you. You ready? Is this indeed a function? And if so, how do you know? So is this indeed a function? Yes.
Just the bottom one?
Nope, is this whole thing. It's all one thing. When you're talking about a piecewise function, you're talking about all sorts of pieces on one graph. Yes? Make sense? You following me that? If you don't know what I'm saying to you, here's what I mean. Once you put something on a function, on a graph, right, on a coordinate plane, you then call it a graph, right? And then you ask yourself, is this graph a function? Are you understanding that? Do you know what it means to graph? It means to etch. You know what it means to etch? It means to make a mark. So when I don't have any marks on this, what is this called? Is this called a graph? No, it's called a coordinate plane. When I do that, have I etched something on it? Yeah. Therefore, it's now called a graph. Okay? All right, so piecewise function. Here we go, right? And then I'll do this. Okay. So I have a bunch of pieces of lines, right? I don't have the whole line, or it wouldn't be called a piecewise, right? So is this a function, yes or no? No. Why is it not a function?
No backup.
Not because there's a break. Not because there's a break in the range either. What do you usually say there, Adam? Okay, right. So easy enough. You just use what we call the vertical line test. There's a vertical line, right? Okay. What does that vertical line do? It goes through two pieces of that graph, right? If you have two pieces, doesn't matter where it is, but if you have two corresponding outputs with one input, it's no longer a function, right? Does that make sense to you? So what I'm asking you over here is this indeed a function? And how would I be able to tell if this is a function or not? Yes?
There's 2 lines that have the same x values.
Right, so do I have 2 lines or any of these lines that have the same x values? Yes or no? And what should I technically be looking for then? Right? What should I be looking for? So that's exactly what I'm looking for. What should I be looking for up here then? Where should I look? Should I look at this? Should I look at this? Yeah, why do I look here? Because this is where the x values are, correct? So this has all x values that are less than -4, right? Okay, so a very quick question. Does this contain any x values less than -4? Does this contain any x values less than -4? Brilliant, so I'm still doing good. So now I can just go to this one. This one contains all x values from -2 to up to 5, but not including 5, right? So then my next question is does this include any values from -2 up into it and not including 5? No. So then I'm good to go. Yes? Put down there, sir? Okay, good. So we do indeed have a function. Wonderful. All right. So now we're going to go ahead and we're going to evaluate it. So here we go. So the first thing we'll evaluate is this. So we'll call this A. You can call it 1, however you want. I'm going to call it problem A. So problem A is going to be, well, if I have f of, and I'll just choose -5. So I evaluate f of -5, right? So really the question is what should I be evaluating then? So f of -5, who do I evaluate? So which expression gets the evaluation? Do all of them get it? No, Nathaniel. The first one, right? So I should be evaluating when f of x, okay, this function is equivalent to 1/2 x plus 4. And why is that, right? Well, you're going to evaluate the function for which the domain exists, right? If this is your domain on the restriction, what is this thing called? So by definition, we labeled it as the input. And you should know that an input, all right, is a value within the domain. Okay? Yes? So if this is a value within the domain, then I need to go find for which domain does this value reside. So the domain that this value resides is it's less than -4. So it resides in this one, so I evaluate this piece of the function. All right? So then I just go ahead and I plug it in. So I say f of -5 is equivalent to, and if you don't want to do all the baby steps, you don't have to. I'm not worried about that, because if you could look at this very quickly and say that this answer is going to be 1.5, then we're good to go. All right? If you can't and you need to do 1/2 times -5 plus 4, okay, then so be it. All right? So this answer, f of -5 is equivalent to 1.5. Okay? We all good there? If you wanted to write this, comma, as 3/2, you can do that as well. All good? Yeah or nay? Okay. That's it. You would claim f of -5 is 1.5, and you're done. Okay? So then we go to part B. All right. So we go to part B, and I say this, right? So I go, okay, well, how about f of 10? So this is my input. So this is my value in the domain. All right. And if you were wondering what back there, so if I don't know if you looked at the backboard when you got into it, it says I can determine a value in the range given a value in the domain. So I'm giving you a value in the domain because it's called the input, so the value in the range. So I need to figure that out. Well, for which one do I get to go associate this with? So I like to just off to the side put f of x equals something, and which piece should I be evaluating? Yep. The last one, which is called the function -3x. So there's the expression, right? So f of x equals -3x. Okay, and I'm going to erase this just so I know that I'm in the video, and I'll come back to C. All right, so I plug it in, I get f of 10, and hopefully we can do some mental math on this one and not actually have to show this, and you get what? Right, -30. Okay, so input, output, input, output. Yes? Yes, sir. They are, because I'm making them up.
So they don't have anything to do with any of that? They just randomly...
Well, they do. I'm randomly picking them so that they tie into this. Yeah. It's me making an example. That's all it is.
What if it has something that, like, that can fit two different equations? You put them in together?
Oh, interesting. That same question always comes up. It's a very good question. We'll talk about that. Give me a couple minutes. We'll get that at the end. Okay? All right. So the question, if you didn't hear it, was, well, what happens if you have something that fits into multiple domains? Okay? And we'll talk about that. All right? Because it's a very, very good question. It's just we have to describe it. So everyone good there? All right, so now we're going to go to C. Well, I don't know. You tell me. Okay, how about f of 0? Yes? So what does f of 0 equal? So I'm evaluating which function? F of x equals what? The second one, which is 4. So what does f of 0 equal? 4. Wonderful. Okay, what does this piece look like on a graph? A straight line. What do you mean straight line? They're all straight lines if we're talking about linear lines. So more specific, that it is a straight line, but that is horizontal. Okay? All right, wonderful. So it doesn't matter what value I pick from -2 up until 5, your answer would always and forever always be 4. Right? Make sense? All right, so then we go to another one. And then we go here, and we do this one. The last one is going to be letter D for now. All right, and we say this. Well, what happens if I have f of, and I'm sure you can guess it. Anyone pick what number I'm going to use?
-7.
No, not -7. 1 million, nope. Nope. Anybody?
40.
Oh, everybody skipped right over the easy one. -3. F of -3, go ahead. You get an answer. Think about it for 30 seconds, get an answer. Not no solution. We're not trying to solve an equation. We only use no solution when we're trying to solve an equation. So no solution doesn't work. Oh, it's a predicament. We do have a mighty little predicament. We'll come back to that.
Any side in a 5/8.
All right. Yes, you saw an infinity sign and a 5 over, not 8. So f of negative 3 is what? Nope. All right, so does anybody, I might have already shared this with you, so you might get the punchline a little quicker. Does anybody know what mathematicians call something that they argue over and they just never ever come to a resolution on? I'll tell you one. You ready? Here it is. I'll give you the most basic example. It's the most ridiculous example that I wish it could be solved so we all have an answer. But what is 5 divided by 0?
0. Anything divided by 0 is 0.
If you say anything divided by 0 is 0, it's undefined. Okay. The answer is this. Now, why is the answer undefined? Well, I'll tell you. Because the answer truly is this. 5 divided by 0 is infinity. If you're asking how, so side note for the day, but the answer to this one is also going to be, by the way, just so you know, undefined. Well, why is it defined? Because here's my definitions of my x values that the restrictions that exist. Yes? What did I never define for you? Right, I never gave you a definition, right? I never gave you a definition for x, and here's the definition for x. This is how it's defined that you find anything less than negative 4, right? Everyone picking up and down? So this is how defined it, that's where your definition is, right? So when I use negative 3, what do I never give you? I never give you a way to define it, to give you an answer. So it's just simply undefined, right? So now, this one is called undefined for a reason, right? Does anybody know what division is? And I'll go over this. Maybe it was the 7th period that I gave this.
Giving cookies to people.
Okay.
So if you have 5 cookies and you give them to 0 people get cookies because nobody's there to take them.
All right, what is 4 divided by 2?
2.
Wonderful.
4 cookies, 2 people.
So you guys have done a very good job of memorizing your multiplication facts because I'm now about to ask you, well, why is it 2? Oh, because 2 times 2 is 4. Wonderful. Right? Yes. So, wonderful, right? So here we go. Wonderful in that sense, right? But you still have not given me the real definition as to why. Okay? You did learn that when you divide, you try to multiply. But when you're doing long division, can anybody tell me the process of long division? Because here is actually the definition. Unfortunately, you may have missed it, but here is a 4 and here is a 2. Can someone please tell me what you mentally do right now? You go 2 times 2. Where do you put your multiplication? You put your other multiplier up here, correct? But here's the thing you all miss. And this is the sad part because this process is the definition of division. What do you now do? Subtract. What am I going to subtract in this case? 4. And what do I get when I do that? 0. And then your teacher said to you this, if it's a 0, it goes in evenly. Right? Which means that you have a remainder of 0. Wonderful, yes? And then your teacher starts doing remainder of 1, right? Well, guess what? Division is also just this. Why is it 2? Pretty simple, because I can subtract 2. And can I subtract 2 from that?
Yes.
Sure, and I subtract 2. Can I subtract 2 from that?
Yes.
Not in the sense of division in the real world sense. Not in the definition. Can I subtract 2 anymore? No. Okay, algebraically, yes. All right. But, okay, can I subtract 2 anymore from this? And the answer is no. And I get what? I get 0, right? What's up, Yash?
Wait, so is it like 4 times 10 to the power of 0 minus whatever coefficient of 2 times 10?
Hold up, you're going to have to talk to me later about this one. You're in the middle. You're in the middle of something else. Your brain's going somewhere else. I'm keeping it basic. We'll talk later, Yash. All right, so you ready? So why is the answer 2? Because the most amount that you can subtract from 4 is group 1, group 2. Yes? You want to follow me on that one? Okay, so the answer is 2, right? So it tells you how many equal amounts of that you can remove from the whole. Okay? Yes? Put down? Okay. So now we go to 5 divided by 0. Right? The answer should be infinity. 5 minus 0. Can I take 0 away from that? Can I take 0 away from that? Can I take 0 away from that? So how many zeros can I take away from 5? Yeah, an infinite amount. Dot, 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 right? To be continued. I can continue this forever. So people will argue that the answer dividing by 0 is infinity, right? And then they argue this. Can you define infinity? Can you give a definition to infinity? And here's the argument. This is where it resides. Someone wants to say that 5 divided by 0 is simply infinity, right? Let's just say what it is. By definition, you're claiming that it's the amount of times you can take something away until you can no longer take it away. How many zeros can I take? 0. But they didn't like the fact that 5 divided by 0, when you asked for a definition, you said what? Infinity. Because what does this little symbol right here mean? What does equal mean? It has a value, and there's a problem with that, and the value is what? Of infinity. There is no value of infinity, right? There is no number, so they don't like the fact that you have to write an equal sign and claim equals infinity. They don't like that. It doesn't sit well with them. So they argued and argued and argued, and they said, fine, just leave it as we never are going to define it, and that's what we're going to have. So mathematicians use the word undefined for values that they either argue about and never could give an answer or conclude or a definitive conclusion. And we also use undefined for when we never give you a definition to go from. So do I ever use a definition for you to go from for -3? And the answer to that is no, because your definitions are in the expressions themselves. Okay? Paying up and down? Okay. So that's it. That's the whole lesson. We're done. Okay. For that part. Okay, that's it. So now, depending on what time it is, how much time do I have? We have until second period goes to 33. So I got a solid 7, 6, 7, 8 minutes. All right. Whew. Let me reload. Do I need, I don't have 7 minutes left. So here comes the question. The question was this. So we'll do graphing Monday. I won't extend the test window. I'll extend how long I'm going to spend on the material. All right? Put down. Your name? Okay. So October 10th is October 10th. That's what it is regardless. I will give you a review guide Friday of next week. I'll give it to you earlier if I make it earlier than Friday. All right? But all of next week will be the last week we spend on chapter 1 and 2. Okay? So if you have any questions about chapter 1 and 2 based off of our course syllabus, please make sure you're asking them within the next week and then the week thereafter, because then you have your chapter test on October 10th. Yes? Okay, wonderful. All right, I'm going to fit a quiz in there. Are you guys cool with a quiz next week? Give you some more points?
Yes.
Quizzes are 2-3 questions for me. Tests are 7 to 8. 7 to 8 questions. You'll have 44 minutes to do 7 to 8 questions, yes. How many points is each question? Depends on what I value that question's worth. No, not on a team one. No, that's team test. All right, so here we go. My longest test last year for an individual test, I believe, was 10 questions. Okay. Listen, you say that now. You say that now. Be careful, right? It does get harder. And 44 minutes, I do want to give you enough thinking time to do it. All right, so here we go. The next question was this. What happens, Mr. Minger, if I have this? We'll change that to a -2, and we'll change that to a -5. And then you ask myself, would Mr. Minger ever go up here and then say this? And you know what? We'll make this an equal to for our example just because it wasn't equal to before. So I could have given you f of -4 here, and the answer still would have been undefined in the previous example, right? So everyone follow me why, right? Because I wasn't actually equivalent to -4. I'm now changing that for this new example to answer the young man's question. Okay? So what happens now if I do f of -4, right? And here's the answer. I can't do it for this problem. Can't do it. Not possible. Why? Yes?
When you have the two x values for the lines, that means it's not going to be a function anymore.
Okay, it's not going to be a function anymore. So good. So why can't I do it for this problem, though? I'm going to change it and show you how you can do it, just not for this problem. Why can't I do it? Okay, so from Algebra 1, you may have missed it. Your teacher probably said, like, f of x is the same thing as y. Wrong. Okay, so very, very close to y, right? But here we go. F of x. You see that? That does more than just assert that it's a y, right? This guarantees. Guarantees what? It's a function. So why would I never do that? Why are you never going to see this problem on the planet Earth? Why would you never see me f of -4? Why? Yeah, then it's not a function. I can't do it anymore. It's not. You'll never, ever, ever see Mr. Minger ever do that, because what I will inadvertently have done is you should write back to me, Mr. Minger, this is a crappy question, right? This is not a function. How can I evaluate a function in function notation if you don't even give me a function to evaluate, Mr. Minger? Okay? So that's a bad question. However, I could still do it if I change one little thing. I change that. I change that. I put a y there, and I put x equals -4. Now, all of a sudden, this is doable. Why? Why is this now all of a sudden doable? I'm no longer, anybody got it? Correct. Y does not guarantee you anything. This is now the basic definition before you move into function. What is the thing you learn about and define before you call it a function? Anybody remember the word starts with an R? At one point, you will all have one with somebody in your life. A relationship, okay? So it's a relation, all right? So it's now called a relation. A relation is no other than claiming that some x and y belong together, that they are formed, that they are created to make something, yes? So now, all of a sudden, this is no longer a function. Therefore, I'm not in function notation, because now I'm saying to you, there are no restrictions on this for which function I use. If I have multiple, can I use multiple? And the answer is yes. Okay, so now I go x equals -4. So I'm just telling you an input. So which do I use? Yes, I would have to use 4, and I would have to use this, because I have now one input that has multiple outputs. Right? Definition of a function says you're not allowed to have that. So you will never see function notation and then this, right? Lucky for you is this whole unit is only on function notation. So will you ever see having to plug it into two different equations? And the answer is no, right? So next year I'll talk to them about this, right? Good question, right? Because that's an important thing to know between the two. Function notation versus not function notation, all right? Y of x is now function notation. It is. Yeah, if I do this, function notation. Can't do it. This is not a function. You gave me something, Mr. Minger, that's not a function. Why are you telling me to evaluate a function when it's not a function? Boo. Boo. Right? So I wouldn't do that to you. I would do that to you. Why? Right? Okay. It could be a trick question, but I wouldn't do that to you on a test. That's just wrong. Okay. I would give you a thinking question, but I would not give you a trick question. All right, so that would be possible if it were just a y. It's not possible if it's a y function. So tomorrow